Hello and welcome. I'd like first of all to thank the organizer of this meeting, Dr. Torabi, for inviting me here and giving me this privilege today. It's an honor to have the opportunity to address such a distinguished audience, and also I thank my three guests and professors, Dr. Sattari, Dr. Khalili, and Dr. Danandemir, to accepting my invitation here. Please interrupt me if there's something which needs clarifying. Otherwise, there will be time for the discussion at the end. Let me start by saying just a few words about my own background. My name is Nasrin Attar. I have finished my postdoc in civil and environmental engineering at Tabriz University. I have PhD in water resources engineering, and I'm interested in stochastic and time series models, numerical modeling, hydroinformatics, and data-driven techniques. You can follow me on Instagram, on Twitter, and this is my LinkedIn ID. So I use R for all my projects. That's why we are here to have this speaking. And you can see my Google Scholar profile with my academic email address. So let's listen my story and how I ended up loving R. In 2018, I went to Australia, Adelaide University, as a sabbatical leave, and there I participated in some workshops such as R Ladies events, and from that time I started loving R and have learned and taught lots of students from all over the world. I have lots of students from Europe, Canada, USA, Australia, and from then till now I have class I'm our classes coordinator, both in person before COVID and online. So another important thing, after contacting the Global Our Ladies organization, I founded the first Our Ladies chapter in Iran as Our Ladies-Urmia, representing my home city. And Our Ladies is a non-profit volunteer organization to help the girls and women for coding around the world. We now have a group of elite ladies as organizers in our team. We have held lots of webinars, book clubs, and co-events with other countries like Australia, Brisbane before. And so you can find our previous videos in our LinkedIn page, Twitter page, and Meetup, and also our YouTube. Next slide. And also, last year, I participated at online user conference, which held on July 2021. I was one of the members of the session Zoom host there. My other achievement is gaining an innovation award in creating a drought forecasting platform in the Global Eye Innovation Challenge with our team in October 2021. And next slide. As you can see on the screen, I would like to concentrate on the application of R in water science and hydrology based on our recent book chapter, which is under review and we will be present soon. By the end of this talk, you will be familiar with the importance of R and its hydrology related packages. During the next 20 minutes, we'll talking on environmental data science, computational hydrology, and hydroinformatic basics. The subject can be looked at under of the following headings, such as environmental data science, computational hydrology, hydroinformatics. So what's R, why we use R, important communities, R pubs, GOSS, hydrological R packages, workflows of R in hydrology, data retrieval packages in R, data tidying packages in R, hydrologic time series analysis tools in R, and also machine learning tools and spatial analysis projects and packages, the use of GIS in R. So the subject of environmental data science, as you know, Earth and environmental science drive data technologies provided comprehensive information about the Earth system. Research on environmental science has a strong tradition because of continuously changing phenomena. So recent theoretical development have revealed that to deal with extensive environmental observations, data-driven methods such as machine learning and deep learning methods can be applied. Next style, I'd like to move on the computational hydrology. The computational hydrology group developed tools to simulate and investigate the planetary hydrological cycle applied to many hydrologic research projects. The computational hydrology develops simulation and prediction tools. So computational hydrology is a discipline that helps researchers to get data, do some pre-processing and data cleaning, analyzes big data, model them in specific workflows, documenting them, visualization, and sharing them in specific web-based clouds, such as, okay, one of them is HydroClient. You can see the website of this, and you can find out the data services here. The other one is HydroServer. This is another open source data tools. The other one is HydroShare. You can find out all the resources here. The next, what's the Hydroinformatics? Hydroinformatics primarily focuses on black box methods to address water-related problems using famous data-driven techniques. Hydroinformatics consists of two words of hydro and information, which carries us into the water world and gives us the knowledge and information using some tools and technologies. From this point of view, the new term of data science and its frameworks come to mind. In hydrology, data science plays a primary role, especially in subfields such as flood, precipitation, groundwater, water quality modeling, and prediction. To apply different data science algorithms, programming languages are essential for computational hydrology and hydroinformatics. So FOSS stands for Free Open Source Software. Different programming languages are used in hydrology such as Fortran, C++, Java, MATLAB, Python, or Julia. But you know, all of them are great languages, but we choose R. So R is a free and open source software. You can find out the Python hydrology tools here in this site, which is about the GitHub. I put all the links at the YouTube caption. So what is R? R was first created by Ross Ihaka and Robert Gentleman at the University of Auckland, New Zealand, and it first appeared in 1993 and currently developed by the R Development Core team. You can see the picture of Robert and Ross. Because of their first name, they tried to use R. This is their first paper, which appeared in 1993. So why we use R? Because it's open source, it's advanced statistical language, it has understanding graphs, it's flexible and fun, it's extremely comprehensive and supports extensions, it has a vast community, and it can relate it to other languages. I have a news for you, and that is you can't learn R. You should learn the basics and learn how to learn more. We should update ourselves every day in order to learn more. So we have important communities for using R. One of them is R bloggers, the other one is Stack Overflow, the other one is R Studio community, Stat Exchange, or StatETHZ or RForge, R Reviews, and Naval website, R Ladies. All of them are very great question and answer communities. The other one is RStats hashtag on Twitter. You can follow this hashtag in order to find all the resources about the R. What's the RPubs? RPubs is an open source place for publishing presentation and scientific resources created in R Markdown. R Markdown documents or presentations simply created within RStudio, and by clicking the publish button, you can publish for the readers and their feedbacks on the internet. The Journal of Open Source Software, which stands for JOSS, is a peer-reviewed, developer-friendly, open-access scientific journal covering open source software from any research field in any programming language. So we can use this software, which is in GitHub, as a publishing platform, and the papers can be searched by the title, tag, author, or language in the search button. I want to show you in this part of my presentation, I'd like to talk about the famous packages which are commonly used by the hydrologists. Hydrological R packages. R packages are also growingly used in hydrological studies such as surface water, groundwater quantity or quality, meteorological data, data tidying packages such as gap filling, data cleaning, missing data, organization of data, hydrograph analyzers like functions to work with flow data, flow trends, flow statistics and indices, spatial data and GIS application packages, statistical modeling, and other packages. The whole list can be obtained from this site. At the end of this presentation, I will show all these websites for you. All packages which are utilized in R are citable. The code below, you can use this code in R in order to cite each packages, and this code gives us the title, author's name, journal name, volume, number, DOI, and URL of the package, which can be added in the reference manager software such as Mendeley or EndNote. So the workflow of R in hydrology has 6 steps. In order to have a reproducible computational hydrological model in R, these stages should be presented in every model, like retrieving data sets, the first step, pre-processing scripts, defining input parameters, splitting data sets into calibration and validation stages, model building, and reporting the results in more innovative ways. This is the flowchart, and this figure symbolizes different stages in R, using R in hydrology. So let's introduce some of the important and commonly used packages in R. One of them, first of all, we want to talk about the packages for data retrieval in R. We have lots of packages, and I selected some of the important and commonly used of packages here. The first one is AWAPER. It's the catchment area climate data anywhere in Australia. All of the data of this package are used for data of Australia. Data retrieval is water quality and hydrology data from EPA and USGS. eCore package can download discharge records for us, fed data, downloading geospatial data from several federated data sources. Metiscan-R can download metadata from over 157,000 environmental modeling stations among 219 countries. And NHDR functions for downloading and networking United States Geological Survey. RNRFA functions for retrieving data from the UK National River Flow Archive. Tidy HYDAT provides functions to address the historical and real-time national hydrometric data from Water Survey of Canada data sources. The next one is water data. It plots the data, addresses some commonly used data problems, and calculates and plots them from USGS, and they are all in daily scale. Climate data, downloading of meteorological and hydrological data from publicly available repositories. CliffRow is a website of New Zealand National Climate Database of around 6,500 climate stations. And GetMet is all about the meteorological data and the ability, it has the functions to format and edit that data. GSODR, automated downloading and cleaning the data from the USA. MODIS tools allows us for easy downloading the MODIS satellite time series. NASA Power is also a daily meteorological data which are interannual and 30 years climatology. MET-R also commonly used analysis methods in atmospheric sciences. PRISM data are presented as gridded rasters at 4 different temporal scales like daily data, monthly, annual, and 30 years normal. The other one is RDWD, downloaded observational time series from meteorological stations in Germany. RNCP functions to retrieve, organize, and visualize weather data. RONNA, which is data and data sets, types, locations, and stations from NOAA data source in API. Our Wonderground is getting the historical weather information from the Wonderground site. SMAP-R acquire and extract NASA soil moisture data. Station RY is a global network of weather stations provided hourly weather data. WorldMet is a package which download over 30,000 surface meteorological sites around the world. And last is FAOStat. It's about the Food and Agricultural Organization of the United States database. So after this, we have packages about the pre-processing of that retrieval data. So we use data tidings in R. We have lots of packages. We have some of them here. Drift R is for cleaning and correcting of water quality data. Climdex.pcic is a computation of extreme climate indices. Climatol is a function to quality control and missing data, dealing with missing data in filling them of climatological series. PLIWAR is a data cleaning package for using visualization of that data. TidyR, cleaning your data by identifying the variables in your data set and using tools provided. Janitor is a package for cleaning dirty data and able to find duplicates. HIFO it's a data pre-processing and visualization in hydrology, and it has the data of precipitation and the data downscaled and resampled with this package. So as you know, in hydrology, we have two main groups. Hydrological models can be physical models, which we use with the physics of the watershed, and the deterministic models, which you use the mathematical equations to model the hydrology types. So we have here the physically based models. One of them is AirGR. It's a conceptual rainfall runoff models and snow accumulation and melt model. It is also used for the educational purposes on APA. Then we have Big Leaf package. It's the calculation of physical and physiological ecosystem properties. The next one is Business. It's about the groundwater quality, groundwater modeling with this equation. Eco-hyd mode is about soil water balance simulation. Eco-hydrology is about the SWAT model and its functions and its calibration of this model. GeoTopBricks is about hydrological distributed model using the GeoTop model. HydroPSO is a particle swarm optimization technique and algorithm which is used for the calibration of the environmental models. And HPVI, uh, this package is used for the HPV hydrological model. Physically based models continued with the KBW Hantush. It's groundwater modeling based on infiltration. Then we have the Raven R. This is a very new package. It's a Raven hydrological modeling framework. The reservoir package is analyze design operation of the water supply storage and reservoirs. RHMS, it's about the simulation, visualization, and calibration of hydrologic systems with the HMS model. RS AlgaR is using the remote sensing models for water quality variables. Stream Diplet R calculates the impacts of groundwater pumping. SWMMR is a stormwater management model. And Telemac is a modeling of free surface flow. Top model is hydrological functions for the top model. And TUV model is lumped hydrological model for education purposes. The last one is WRSS, is an abbreviation of Water Resources System Simulator. We have in the next category, we have the deterministic or statistical models for hydrology. The first one is Cosmos. It generates multivariate and univariate non-Gaussian time series. HydroApps is using to regional analysis of hydrological applications. HydroGeoF is a goodness of fit measures between observed and simulated values. I really like this package. Hydromi is parameters in infiltration and water retention models. LPM stands for long memory models to hydrological datasets. NSRFA is a regional frequency analysis model in hydrology. RMAWGEN is stochastic generation of daily time series of temperature and precipitation. SCI is used for the functions for generating standardized climate indices. Soil water retention or conductivity curve can be used by this package. Synthesis is about generating synthetic time series. The next package is SPEI, is one of the drought indexes, standardized precipitation evapotranspiration index. WASP is a wavelet-based variation transformation method. Evapotranspiration is a function to calculate potential evapotranspiration and actual evapotranspiration. MBC is a multivariate bias correlation of climate model output. Meteoland is a function to estimate weather variables. Musica, a package used for multi-scale climate model assessment. OpenAir is a package and tools to analyze, interpret, and understand air pollution data. QMAP is also climate model simulation using quantile mapping. MODIS TSP is a MODIS satellite data can be downloaded along the pre-processing land products data. So we have some of the important time series packages which we can use for hydrological data sets. One of them is Fable. It's a famous package. It has the tools for fitting univariate time series models. And the next package is Forecast, provides time series forecasting tools. Profit is a package that analyzes time series using an additive model that fits yearly and weekly, and also seasonality to nonlinear trends. T-series is a time series analyzes and computational, which fits some Arch models. TSDYN, some of the nonlinear time series models with regime switching. MTS is a analyzing of multivariate time series. TS-rep are methods for representing time series, and wavelets, the wavelet methods. All, some of the important packages about the time series was written by a professor at Monash University, Professor Hindman. So we have also packages, some common and important packages for machine learning application tools in R that we use NNet, neural network packages, or DeepNet, deep learning packages, RPart, three structural cart models, and for classification. Arveka is about the software of Veka, which implements and join with the R. Is about the three structural models for classification again. The random forest model is about using to regression and classification. XGBoost for boosting, RG node for optimizing using genetic algorithms, and FRBS for fuzzy rule-based system. We have also some packages that we can use GIS in R. As you can see here in this figures, you can see the world map and also our country's map, which I draw all of them in R. We have some important spatial analysis projects and packages such as SP package. We can plot points, lines, polygons, all in R using SP package, map tools, and shapefile packages, which serves for assessing vector data in R. RGDAL package also provides functions to read and write a lot of grid and vector formats. Raster packages provide access to data in raster formats, and also doing lots of things like handling large raster files or doing algebra on that raster files, and etc. All of them can be used with the raster package. So we have another packages like rasterviz for complementing the raster packages, which provides a set of methods for enhanced visualization of rasters. RGeos package for working with manipulation data, vector data, like topology operations or geometrics. GStats package also offers a wide range of univariable and multivariable geostatistical modeling methodologies and prediction and simulations that functions. The other one is our Google Maps, which provides tools to access Google Maps data within R. Also, we have the ggmap package that allows the easily visualization and spatial data on top of Google Maps, OpenStreetMaps, or etc. OSMAR package is a vector data from OpenStreetMaps is also available for downloading in R. As a conclusion, I want to tell you that R is a rapidly growing software with many libraries and packages. Recently, many scholars in different fields have used R for their daily use and producing publication quality graphics. Hydrologists also use this software to tidy, transform, visualize, model their hydrometric data. And also our programming language holds interests among the hydrologist community and this causes them to develop useful and efficient hydrology packages, workflows. Hydrology are related events, conferences, holding training courses such as the application of R in hydroinformatics, and so on. I want to thank all of you for your attention and listening to this webinar, and I will put all the links which are in this slides in the YouTube channel at the comments. If you have any question, you can find me you can email me. Also, you can find me in other applications such as LinkedIn, such as Twitter or Instagram, and also my academic email. So thank you so much, and bye.